Hello guys, welcome back to VC Tech. Have you ever wondered how your phone knows where to send data when you want to open Google or YouTube or even Facebook? I mean, seriously, your phone doesn't know where Google servers are, your laptop does not know the path to YouTube. So, how does the data know where to go? Today, I'm going to answer a very important networking question. Is there a scenario where a device doesn't know where to send its data? The answer to that question is yes. As a matter of fact, it happens every single day. By the end of this video, you understand how devices make routing decision, what a default gateway really is, and what a default route is, and why this concept is the foundation of the internet. So with that being said, let's head over to the PowerPoint and see what we have. A default static route is a route used when no specific route exists or is specified. It acts as the last resort path for unknown destination, and it is represented by 0.0.0.0/0 subnet, meaning any destination and any subnet. It is commonly used for internet connectivity. Why default static routes are used is it reduces the size of a routing table, it simplifies the network design, it also allows internal network to access external network. I'm going to explain what this means when we get to the configuration phase, as it improves routing efficiency. The configuration to a default static route, this is how it's been done on a router. You say IP route 0.0.0, any destination with any subnet mask should use the next hub IP. Now, this is what we are going to do when we get to the Cisco Packet Tracer Lab. We'll use this configuration, and we'll be having also a backup default route, a secondary route that will be used only when the primary route fails. It is configured using a higher administrative distance number to provide redundancy in a network design, and we'll talk about this in detail in the next tutorial. So, with so much said, let's head over to the Cisco Packet Tracer Lab and configure a default static route. I've already assigned IP address to all the interfaces on the router. For the ISP router, as we have over here, it's taking the IP address of 128.64.10.1 for interface gig 0/0, which is this interface over here. And for interface gig 0/1, we'll be taking 200.150.1. And also the ISP backup route, we have 10.10.10.1 and also 200.150.1. So the 200.150.1, we have that for this and also for this, as we are going to try to test connectivity and also show you what a primary route is and a backup route. Now let's configure a default static route. Once again, a default static route is used when a router does not know the specific route to a destination. Now, for this host device, if this device wants to communicate with this device over here, of course, it sends its packets to the default gateway. So that is what a device does when it does not know how to get to a particular device in a different local area network. It sends the packets to the default gateway. Now, on the other hand, when a router does not know how to get to a particular destination, that is where we configure a default static route. A default static route is configured when a router does not know how to get to a particular destination. So let's head over and start the configuration, as we have here a default static route, and this is how the configuration is going to be done. Remember, it always uses the next hub IP. So let's configure that on the router for the local area network. Let's configure that here. And we can configure a default static route by saying IP route with 0.0.0.0 with any subnet mask should use the next hub IP address. Now the next hub IP address for the ISP router is interface gig 0/0, which is 128.64.10.1. So we are going to put that here. So 128.64.10.1. So this is the next hub IP that is directly connected to the ISP router. By doing this, we've configured a default static route on this router over here, telling the router that when it does not know how to get to a particular destination, it should forward that traffic to the ISP router over here, which is the default route. Let's also configure a backup route for the default static route when the primary route is not active. So we also do the same configuration. Let me just take that out. So the same configuration with a higher administrative distance number. So we'll be using 130. So whenever this route is not active, this route would kick off. Let's also configure a static route on the ISP router so it knows how to forward the data back to our local area network router. So when configuring a static route, it's just IP route with the destination, which is 192.168.1.0 network with a subnet mask of 255.255.0, and it should use the next hub IP to get to that destination, which is the next hub IP on this router is interface gig 0/0, that is using 192.168.10.2. So we'll be doing that on this router 10.2. So 128.64.10.10.2. Now we've configured a static route on the ISP router to forward traffic back to this router over here whenever this router demand or makes use of the routing table of the ISP. Let's also configure a static route on the backup router, and we will test that shortly. So we say IP route. We want to route our traffic back to the network of 192.168.1.0, the subnet mask of 255.255.0, and we want to be using the next hub IP. The next hub IP is 10.10.10.2 on this router. So we see 10.10.10.2. So on the backup router, we just configure our static route, while on this router over here, we configured our default static route and also a backup route when the primary route fails. So let's assign IP address to this host PC. Then we try to ping the network of 200.100.50.0 network. So assign IP to this device 192.168.1.1, right? One 192.168.1.5, and we also want to set the default gateway, which is 1.1. Now guys, let's try to ping the network of 200.100.50.5. As you can see guys, we are able to ping this network over here Remember, we don't have the destination on our routing table, but we've already configured the default static route, telling this router that whenever the destination is unknown, it should forward that traffic to the ISP router. Now the ISP router will check its routing table and decide if it has that network or if it's also going to forward traffic to the next router. So let's also trace route and see what routes that our device is taking. Remember, we have the primary route and also the backup route on this interface. Let's trace route from this device and see. So 200.100.50.5. Let's see the route is taking to get to that destination. So it left our default gateway of 1.1 and it went to the next hub of 128.64.10.1 before it got to the destination of 50.5. So which interface is 128.64.10.1? That interface is on this router, because this is a primary router and whatever traffic that comes from this host device, it goes to the primary router. Now let's also try to do this, and let's delete the connection on the primary router and try to ping one more time and see what route it's going to be taking to get to its destination. I'll bring this down a bit so we can. So let's try to ping 200.100.50.5, and we will also trace route and see the route is taken to get to that destination. As you can see, guys, we are able to gain communication from our device over here to our backup route, because that's the route that is active, because the primary route is no more active. So the backup route has not kicked up. Let's also check the route that it's taking. So trace route, and as you can also see, it is taking 10.1 interface, which is on this router over here. So this is how a default static route and a backup route works. I'm going to talk about a backup route in the next video to come, so stay tuned. If this video helped you understand how data finds its way across network, why not hit the like button, subscribe if you are learning networking, routing, OSPF, or a real world network design. Thank you guys, and see you in the next video.